Hello and welcome back to another Alice1101983 special. Now, this is not sponsored by anybody. I paid for this with my own money, but I just like browsing sometimes. When you shop on eBay, you kind of have to, search for what you want, but when you find a seller that sells mostly what you want, it's nice to be able to just browse, and that's what I did, and that's why I have this. Also, you might notice there's some light coming from this side. I'm trying a new lighting setup, so I still have my main light over this way. You see it's kind of like it's a warm white, it's kind of orangey. And on the other side, see how it's whiter? This one is a cool white. Just experimenting. Let me know how it works out in the comment section. But without further ado, I should say, let's get this open. Now there's a few kind of fragile things in here, so I got to be careful. Ooh, I didn't actually rupture the inner bag there. Okay, 1, 2, 3, 4, 5 things. So let's take a closer look. Well, let's start with these two guys. Now I'm not sure if I'll be able to test all the things that I have ordered, but we'll certainly take a look at it. So these are actually a passive component. There's one, and there's another. I'm not sure if it's in focus, but I sure hope so. So what these things are is they are sliding linear potentiometers. Now I do have some sort of remote control type stuff that I am planning, and so these will be useful for controlling, like, having like a speed controller, having a fader from left to right, or whatever. I actually wrote down on my notepad here. So these should be 10K potentiometers. They cost me $2.28 each Canadian. That's about $1.70 each American. And it's interesting, they have dual outputs. I'm not sure if they're dual potentiometers. I'm looking at the tracks here. It looks like out A and out B. Yeah, I think they are actually dual potentiometers. So they have two separate outputs. Wonder if this actually affects anything. So let's set up here and try to read the resistance off these. So I have my trusty multimeter here, and how potentiometer works is, you see there's a sort of like a OTA and OTB. I think it's output A and output B. They look like they're reading the same thing, though. I'm not sure. So the output is over here. No, they have different tracks. They definitely have different tracks. Okay, but how a potentiometer works is it's a variable resistance between two sort of posts. So you have power on VCC, ground on the ground, and then you're going to have a variable resistance between VCC and output, and ground and output, and they'll be inversed. It's sort of like, I guess I'll draw a diagram after, but we should expect that at one end it'll be very low resistance, and at the other end it'll be the full 10K resistance, or roughly 10K. And if we swap the leads around, if red's on out A and black is on ground, if we swap the ground for the VCC, it should be the opposite. So right now the slide is all the way down, so we should see either 10K or nearly nothing. And then if we swap it, we should see the opposite. So, okay, so we have like 1 ohm resistance, so not very much. So if I just leave the red where it is and I move the black one to VCC, I should have roughly 10K of resistance. Yeah, 9.72, roughly 10K. I'm not sure where the inaccuracy comes from, if it's this thing that's inaccurate or my meter. Who knows? And if I slide this, yeah, see, about halfway, about 5K, and slide it all the way up. 5.1 ohms, and if I swap the black back over to ground, should have, yeah, there we go, full 10K. And that should be about the same on the other side. Yeah, full 10K. And swap the lead. Yeah, nearly nothing. There we go. I moved it a little bit. But that's pretty cool. And this will be as quick as you want. Actually, if I can hold the range, range hold. That won't work actually. Put it all the way up here. Okay, so if I hold the range here, yeah, see how this is like instant. There's no messing around. You can move this as fast as you want because it's just splitting a resistor. You won't have any delay in this. We can try the other one too. The other one should be identical. So I'll put ground, and over here I put B. 10K. This one's a bit high actually. 10.1 and 0. 10K, 0. 10K and 0. So yeah, nothing too special to see here, but it's just a potentiometer with an interesting form factor. So, you know, you can picture these things being set up like this, and you know, you can move the position or whatever. And they're not very expensive. I mean, you know, $1.70 US a pop. No brainer. If these are really nice, if I start using them in projects, I'll just order a whole bunch of them, you know. So you have a whole control panel of them. That's pretty sweet, and I'm sure some of you didn't even know that linear potentiometers existed. Let's go on to the next one. Next one up is this tiny little piece. And this here is, I guess they call it an Arduino sensor, but it's not really an Arduino sensor. So it comes with these pin headers here. And what this is a 3-axis gyro. So if you can see, if I focus down properly, I'm not sure if I am, see Z, X, and Y. So this thing should be able to verify tilt in this direction, X, this direction, Y, and this direction, Z. Not sure. Which one's the American one? I always forget. But yeah, this thing is absolutely tiny. You can't really get these gyroscopes in a larger form factor, like a breadboardable form factor. So I decided to get it in this format, so you can just solder some pins in and work with it on a breadboard. And then if I want to integrate it into projects, then I would, you know, get a board made or whatever, buy an adapter. Not sure. But yeah, really interesting here. I think this is SPI, because you see there's ground, VTC, VCC, chip select, int 1, int 2, SDO. Not sure what SDO. Oh, serial data out. I'm not sure actually. SDA and SCL. That's the serial clock. Not sure which one's which here, but I'll have to figure it out. I'm gonna make its own video. It's supposed to be a ADXL345, which is what it says here. Just looking at the actual gyro, can't really tell what's going on. But yeah, this was expensive. This was a whole $1 US, so $1.30 Canadian. So I figured it was pretty cheap entry into the world of gyros. So yeah, figured I'd give it a shot. Oh, here's the actual gyro number, GY291. So yeah, pretty interesting. But I don't think I want to go hunting for a sketch for it. I think I'll make its own video. But yeah, for $1, it's ridiculous, right? This is with a custom PCB that the manufacturer has made. This is the whole thing, and in a order of one, right? I only ordered one of these. Can you imagine how cheap it is to integrate these things into cell phones? If I personally can order a single one for $1, nuts. No wonder cell phones are getting cheaper. Well, I guess not Apple cell phones. Next one up is this guy here. And this is interesting, actually. Not sure if a lot of you know this thing exists. This here is another variable resistor, but except this one is a decade resistor box. So basically you read the resistance between here and here, and you can switch in and out resistors, and it goes from 1 ohm all the way up to 1 ohm shy of 10 mega ohms. It's supposed to be 1% tolerance, and it is a half watt. So let's see if we can make this work. It seems like right now, not sure what it's setting it's at, but let's put our pins onto here and see what we get. So these are nice multimeter leads. Let me grab onto these things. Oh yeah, okay. It's on the max. It's actually, I'm a bit close for this, but that's okay. There we go, now you can see. So this is at 10 mega ohms, and what you do is you move the decade that you need. So this is the megs here. Let's go to 1 mega ohm. That's a 0. That's a 1. Oh yeah, and all these have to be back. There we go. Let's reset this to basics. Put all zeros. This is basically the cheapest way to have a decade resistor box. There we go. As the significant figures drop off. And there we go. This should be the 1 mega ohm position. And we're pretty close. 0.994995 mega ohms. So 995,000 ohms. So that's pretty good. And we can set pretty much any value. Now, I know the low values are tempting, but I don't think they're very useful. So here we're all at zeros, and we're getting half an ohm. I'm going to try to put these together. What do we get? 0.3. So we have 0.2, 0.3 ohms of resistance just in the wires here. So let me zero that out. Relative. I'm going to connect these back up here. It didn't do any better. Still 0.3. So I'm going to move. This should be 10 ohms down here. So I'm going to move this to the 10 ohm position. What do we got? 9.2. It would be interesting actually to find out which one of my multimeters are more accurate in the ohms range. If I remove the relative, we're actually closer. So that's not too bad. And I love this because you can pick basically any resistance you want. So let's say you're not sure, maybe you want 1.5K, for example. So here's the 1000 ohm mark, so I'm going to put 1. And then I want 500, so 1,500, so I move this guy, the hundreds, to the 5 position. Is that the 5 position? Yep. And there we go, 1.5k ohms. So this thing's great. This is, let's see, what do my notes say? Decade resistor. This cost me $3.25 US, $4.37 Canadian. And that's pretty cheap actually for these resistors, this board, everything already made. I've seen other solutions where they've used switches, but there's so many contacts, right? You need 10 position switches, and you need 1, 2, 3, 4, 5, 6, 7 of them. That's quite a few. So I probably would have avoided the 1 ohm decade because it's not very accurate, and I never really need a resistor, you know, between 1 and 10 ohms. But yeah, at least the 10, 100, 1K, 10K, 100K, and meg ohm range is quite useful. So yeah, I'm going to use this quite often. I think you'll see it in my prototyping videos when I'm not quite sure what I'm building or what kind of resistance I'll need. You're going to see this thing pop up. I figured I should get one. As soon as I seen it on Alice's store, I picked it right up. So next is this guy, which is going to be used for projects coming up soon as well. And again, they call these like Arduino expansion boards, but they really don't have too much to do with Arduino. Yeah, you can use them with microcontrollers for sure, but I mean not specifically Arduino. But what this is a I2C communicatable PWM servo driver. So you can actually use this to send out 12-bit PWM signals to 16 different servos. So you can control 16 servos with one Arduino. And I think the DigiSpark, the little guy, hold on a sec, this guy here. So I think this guy can communicate I2C, so you can have this tiny little guy that costs $1 something controlling 16 servos, which is ridiculous. So over here you have ground, you have 0E, not sure what 0E is for. Then you have serial clock, serial data, and VCC. Ground 0E, not sure what 0E is for. So on the back it says use V plus for servo supply, which I'm guessing is in this way. You've got a chip on there, which is the PCA 9685PW. Right there you have, I'm guessing these are either pull up or pull down resistors. You have adjusters here for the I2C address, which is very good. And it looks like you can actually daisy chain this because it actually says ground OE, SCL, SDA, VCC, and V plus on the other side as well. Very interesting. So it says, I don't know if I'm in focus. Maybe. It says VCC 3 to 5 volts, logic level 3 to 5 volts, which is perfect. V plus 6 volt max, frequency 40 to 1000 hertz, so 1 kilohertz. Terminal block is reverse polarity protected. Side breakout pins are not. So yeah, you just take your servos and you insert them into these channels. You control 16 of them. This is ridiculous. I don't even think I have 16 servos, but I have a whole bunch. So when I make a video just for this board, I'm going to connect as many as I can with a strong enough supply, and we'll see if we can get them all doing different stuff. That would be awesome, especially if there's a pre-built library on the Arduino IDE to handle it. But yeah, for now, not too much we can do. Let's move on to the next one. So last but not least is this. This is a solar cell. Now, I'm really interested in getting into solar projects, but I was always afraid of ordering these and kind of what shape they're going to show up. So I decided to give this a shot. This guy is $2.10 US dollars. So, you know, $2.80, I think, Canadian. I'm not sure if I forgot to mention this guy was $2.50 US, which is about $3.40 Canadian. But yeah, this guy for just under $3 Canadian. I believe it's a 6-volt, 1-watt cell. There we go. Peel is done. And so let's count here. Each solar cell should provide roughly half a volt. So it should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, there are 12. Not sure if this is UV protected or not. But yeah, I guess the only thing we could do, because I do have a lot of lighting. There you can see my spotlight on one side, and there is an LED bulb on the other side. The only thing I guess we could do is solder some wires onto the positive and negative terminal and see if we can get some voltage out of it. So let me get ready for that and I'll bring you right back. I think I need to up my wire game because I have 30 gauge wire, which is extremely tiny, which is fine. It's good for a lot of cases. But the next size up I have is 18 gauge. I got nowhere in between. Maybe I should get some like 22 gauge or something wire. But anyways, here's this 30 gauge wire should work. I don't think we're going to pull that much current, especially indoors, but yeah. So I have some leaded solder, 6040 rosin core. Oh, no, 6337 rosin core. I've got my iron a little bit higher than I'm used to. I have it 360 degrees science. And I don't know how resilient this is to heat, so I'm going to have to sort of try to get in, get out quick. That's why I want to heat it up fast. Drop some solder on there. Yeah, that's not too bad. Hopefully I didn't damage it though. Same thing here. Faster. Okay. Let that cool for a few seconds. Don't want to thermally shock it. Now, it's funny, there's like some resin on the side here. There's like a scrape here. Quite interesting how they made these things. Okay, we will now flow this wire on. That's one. I do like this thin wire. I feel like I need a little bit thicker. And that's two, and maybe different colors too for you guys' sake. So that's soldered on. I think I want to zoom out a little bit. Let's see if I can do that here. I know it's changing the exposure a little bit. That's okay. You guys can deal with it, right? Some of you have been watching my videos since the very beginning when I had no production value at all. Not that I have much more now. Anyways. Okay, so multimeter. And yeah, I know, this multimeter is junk. That's okay. We're actually going to test this multimeter pretty soon. Alright, DC voltage. Now it doesn't matter which way I connect this. I'm just going to get either positive voltage or negative voltage. Ooh, nice. Under my studio lights, 5.8 almost. I'm going to point this a little bit up. 6. Oh wow, get almost a full 6 volts. Oh, I was shorting a little bit there. Come up closer to my spotlight. 6.5 volts and go right up to it. Ooh, 7 volts. That's nice. That's nice. Now, if you do the math, I think this said it was a 1-watt panel. And so 6 volts, 1 watt. Is this getting warm? No, not yet. I was like, what? Why is this changing voltage when I press on it? It's just because I'm blocking the light. Derp. Okay, so 6 volts to get 1 watt out of 6 volts. It's P equals E times I. So I'm going to get 1 divided by 6. Should get about 1/6. I don't even have my calculator on me. I should get 1/6 of an amp, I believe, if I mathed it right. Alright, so let's try this. I'm going to actually flip this upside down. Don't want any current flowing. Going to go into milliamp because it should be good. Yeah, well, if I blow the fuse, I blow the fuse. It's not a big deal. I think it'd be fine. Okay, set this into milliamps. Okay, currently no milliamps. I'm going to flip this around. Yeah. 3 milliamps. This is loaded down big time, right? So I'm going to bring it up close. 6, 8, 10, 11 milliamps. Yeah. So we're not reaching very much because we're not in full sun. But, you know, 11 milliamps times 6 volts. That's actually 0.066 watts. Not very much, but you know, we're not out in the sun, so I'm gonna have to try this out in the full sun and see how much we get, but I don't suspect it's gonna be very much. Plus, it's sort of the end of winter right now in Canada, so I'm not sure if we're gonna get full sun. So yeah, you know, plenty of time this summer to give this a shot, but for now at least we know it works. We know I just didn't throw you know, $3 into the ether. But yeah, looks pretty neat, and I think it works well enough as long as, like, I take tests in full sun. As long as in full sun it performs okay, then I should be good to order a whole bunch, and we'll see what we can do with them. And so that's it. These 5 items, I guess 6 if you count them individual, make up today's mailbag, which was the second Alice1101983 special. If you have a favorite eBay seller, let me know who it is in the comments below, and maybe I can do a special on that eBay seller. I'm not sure. I don't have any sponsors. This all comes out of my own pocket. I do have a Patreon if you'd like to support me and support the mailbag projects and the projects that go along with them. The link for that is in the description below. Once again, thanks for watching.